The Japanese regime was by far the darkest time in Puerto Princesa's history that left devastation scars up to the present. A Palaweño by the name of Dr. Higinio Mendoza stood up for the people and resulted in his execution on January 24, 1944, and was buried along with other troops in the exact area where this park stood, thus the name Mendoza Park. This park is located in the heart of the city with a prominent statue of the local hero. Now, the park was recently remodeled with colorful lights highlighting the fountain with a statue at the center. The Palawan cherry blossom trees alongside the monument are in full bloom every summer, making the park naturally appealing.
Mayad nga adlaw, mga Palawenyo! Good day, Puerto Princesa! Hello, grade 9 dream learners! Join me as we learn and discover the world of science. I am your teacher Jen, and today, let us explore the wonder of things happening around us. Welcome to Puerto Princesa Dream TV, your digital classroom as you walk through the lessons in grade 9 science. So sit back, get ready with your pen and paper, and have fun learning. At the end of this video lesson, we will be able to describe the internal structure of volcanoes, explain how volcanoes erupt, discuss the different factors that affect volcanic eruptions. Are you excited? Let's start our new learnings and enjoy! Before we continue, let us have this activity. I will give you 5 questions, and you are going to analyze the given situation. Choose the letter of the correct answer from the given options and write it in your paper. You are given 5 seconds to answer each question, and when you hear this, that means the time is up. Are you ready? Let's begin.
Directions. Read the questions carefully. Choose the letter of the correct answer. Number 1. Why do certain types of volcano erupt less violent than other types of volcanoes? A. Low viscosity magma and high gas content. B. High viscosity magma and high gas content. C. Low viscosity magma and low gas content. Or D. High viscosity magma and low gas content. Number 2. What do we call to the hot molten material that breaks through the surface of the earth? A. Fluid. B. Lava. C. Liquid. D. Magma. Number 3. What structure enables the flow of magma to reach the Earth's surface? A. Central vent. B. Conduit. C. Magma chamber. Or D. Surrounding vent. Number 4. Which of these does not affect magma's viscosity? A. Chemical composition. B. Concentration of gases. C. Pressure. D. Temperature. Number 5. What structure permits the magma to flow through the vent from the magma chamber? A. Central vent. B. Conduit. C. Magma chamber. Or D. Secondary vent. Check your answer on the screen. Number 1. C. Number 2. B. Number 3. C. Number 4. C. And number 5. B.
How's your score? Did you get a perfect score? If yes, that's great. If no, don't worry. As we go on with this lesson, we will deepen your understanding so you can get a higher score at the end of this episode. Don't forget to take down all important details for you to be guided and cope with the lesson.
What you are currently witnessing is a gigantic phreatomagmatic plume emitted at Taal Volcano at exactly 3:16 p.m. today, July 1st, 2021. Alert Level 3 was raised over Taal Volcano around 3:37 p.m. today due to a 5-minute eruption which generated a dark jetted plume approximately 1 kilometer high. The event recorded mid-course as low-frequency explosion earthquake but was not preceded by seismic or ground deformation precursors. However, anomalously high volcanic sulfur dioxide gas emission preceded the eruption, averaging 14,241 tons per day and 13,287 tons per day, respectively, on 28th of June and 1st of July, morning of today, 2021. A marked increase in volcanic gas upwelling also began on 28th of June 2021 that generated plumes that rose some 3 kilometers above Taal Volcano Island. The Alert Level 3 status of Taal means that there is ongoing magmatic extrusion at the main crater that may further drive succeeding explosions. PBOX strongly recommends Taal Volcano Island and high-risk barangays of Bilibinuang and Banyaga, Agoncillo and Boso-Boso, Gulod and Eastern Bugaan East, Laurel, Batangas Province, be evacuated due to the possible hazards of pyroclastic density currents and volcanic tsunami should stronger eruptions subsequently occur. The public is reminded that the entire Taal Volcano Island is permanent danger zone. Please tune in for more live updates. Hajarena Sarail Dumadag, reporting live at PBOX DOST station. Quezon City, back to studio.
Do you know what causes volcanic eruption? If yes, that's impressive. If not, don't worry, for this lesson will provide you knowledge on what happens when volcanoes erupt. Let's explore first the internal structure of a volcano. On the surface of a volcano, there is a vent that serves as opening which releases lava, gases, ash, or other volcanic materials. The channel or pipe-like structure through which magma flows to the surface of the earth is the main or central vent. The secondary or side vent is where some magma can escape through the sides of the volcano, particularly if the main vent is blocked. Connected to the vent is another pipe-like structure called conduit into which magma flows. Another hollow structure inside the volcano is the magma chamber, where the molten rock, called magma, is stored and gases are collected underground. Volcanic materials pass through the conduit from the magma chamber during an eruption and will be ejected through the vent into the surface. The variety of volcanic eruptions ranges from devastating explosions to moderate lava gurgles. All volcanic activity relies on the same underlying concept.
In essence, all eruptions result from magma being forced up to the surface from under the earth where it erupts as lava, ash, and rock. What do you think are the mechanisms driving this process? What exactly causes molten rock or magma to rise from the interior of the earth and erupt into the landscape? To understand how volcanoes erupt, let us have a recap on the structure of the earth.
The outermost layer of the earth is composed of the upper mantle and crust, which is collectively called the lithosphere. Only a portion makes up the crust. It is cold and rigid and composed primarily of silicate rocks. Below the crust is the Earth's mantle. Conditions vary significantly from the crust up to the mantle. Pressure increases dramatically and temperature can reach up to 1000 degrees Celsius. This makes the rock viscous enough to behave like a liquid. As the mantle melts, magma is formed. Melting happens when tectonic pull apart or one plate is forced down under another.
Now, here is the volcano's eruption mechanism to better understand the spontaneity of volcanic eruption.
Under the crust, this viscous molten rock or magma gathers into the magma chambers. Since the magma is less solid and lighter than the surrounding rock, it rises to the surface. As the magma rises, bubbles of gas form inside it. Pressure causes volcanoes to erupt. The pressure is caused by some combination of heat and or gases. When the pressure is too high, an explosive eruption can happen, which is dangerous and destructive. An injection of fresh magma into a chamber that is already filled with magma is similar or different composition is another way that causes volcanic eruptions. This injection forces some of the chamber's magma to move up in the conduit and to erupt at the surface through vents. When water interacts with hot magma under the surface and produces steam, it can produce enough pressure to cause an explosion. The hot molten rock is called magma when it is below the surface. It erupts as lava, ash, and volcanic rocks when it hits the surface.
Volcanic activity can be very interesting. Some eruptions can be very explosive, while many others are not. Previously, you have learned about the different types of volcanic eruptions and types of volcanic holes. Do you know that these are all because of the internal structure of a volcano? Similarly, this factor also determines the nature of an eruption.
Magmas emerge from the Earth's mantle and travel upward through rock cracks. The viscosity of its magma determines the speed of its flow. Viscosity is a measure of a material's resistance to flow. It is also known as the thickness and stickiness of the fluid. The more viscous and thicker the material is, the higher its flow resistance. For instance, syrup is more viscous than water. Viscosity is controlled by the temperature of the magma, its chemical composition, and the amount of dissolved gases it produces.
Now let us have the factors affecting viscosity. The first factor is temperature. The higher the temperature of the magma, the lower its viscosity. On the other hand, the lower the temperature of the magma, the higher its viscosity.
Composition of magma. Magma with high silica content is more viscous than those with low silica content. Silica is a compound consisting silicon and oxygen. Philippine volcanoes have high silica content in their magma. Thus, volcanoes erupt violently. Amount of gases. Gas, mainly water vapor, dissolved in magma appears to increase its tendency to flow. The dissolved gases expand and create small gas bubbles in the magma when the vapor pressure is great, pushing the magma to the surface. As the bubbles escape, that can trigger an eruption. If the magma's composition is thin, the gases from the rising magma will easily escape. The lava flows freely from the vent down to its slopes, uniformly and continually releasing pressure. Since pressure does not accumulate, there is no violent explosion. If the magma is thick and pasty, it is not possible for the gases in the magma to pass freely and can create great pressure. Violent eruptions occur due to high pressure levels. The gases violently escape and throw out the massive amount of solid hot rock, as well as lava, dust, ashes, and gas clouds. When a very thin and running magma erupts, it forms gentle mountain slopes, while a very dense magma erupts explosively and forms a fat lava flow and steep mountain slopes.
So if you see a mountain formed by a volcano, by merely looking at the angle of its slope, you can easily predict the viscosity of the magma that formed it. Still enjoying with our lesson? Let us now have an activity.
Directions. Identify the different parts of a volcano. Color each part using the given color corresponding to their number on the table. Then, give a brief description of each part. You are given 1 minute and 30 seconds to answer these questions.
This activity is entitled Volcano Battle.
Materials: 1 bottle of Coke Sakto, water, and 1 empty bottle of Coke Sakto. Procedure: Number 1. Pour out half of the drinking soda into a glass. Then, close the cap. Number 2. Shake the bottle for 1 minute. Number 3. After 1 minute, slowly unscrew the cap of the bottle. Observe what happens. Number 4. Get the empty bottle and half fill it with water. Number 5. Shake the bottle for 1 minute. Number 6. After 1 minute, slowly unscrew the cap of the bottle. Observe what happens. Directions. Check the box that corresponds to your answer. Question number 1. What did you observe in the bottle with drinking soda after shaking and opening its cap? Bubbles form on top. There was an explosion of bubbles after opening the cap. Bubbles form on top. There was no explosion of bubbles after opening the cap. Question number 2. If you will shake the bottle for 2 minutes or more, what do you think will be the behavior of drinking soda when its cap will be slowly unscrewed? More bubbles will form on top. An explosion of bubbles after opening the cap will be observed. More bubbles will form on top. Greater explosion of bubbles after opening the cap will be observed. Question number 3. What did you observe in the bottle with water after shaking and opening its cap? Bubbles form on top. There was an explosion of bubbles after opening the cap. Bubbles form on top. There was no explosion of bubbles after opening the cap. Question number 4. If you will shake the bottle for 2 minutes or more, what do you think will be the behavior of the mixture when its cap will be slowly unscrewed? More bubbles will form on top. An explosion of bubbles after opening the cap will be observed. Bubbles form on top. There was no explosion of bubbles after opening the cap. Check your answers on the screen. Question number 1. Bubbles form on top. There was an explosion of bubbles after opening the cap. Question number 2. More bubbles will form on top. Greater explosion of bubbles after opening the cap will be observed. Question number 3. Bubbles form on top. There was an explosion of bubbles after opening the cap. Question number 4. Bubbles form on top. There was no explosion of bubbles after opening the cap.
In the activity, you have seen the effect of shaking the bottle on the dissolved gas in drinking soda. As you increase the time of shaking, greater explosion of bubbles was observed.
Let us relate this concept to what happens inside a volcano. Magma inside the volcano has gases dissolved in it. and these gases increase the tendency of magma to flow. When the pressure is great, the dissolved gases expand and produce small gas bubbles that push the magma to the surface. It can cause an explosion as the bubbles escape. The greater the pressure, the greater the buildup is, and more violent the eruption will be. Volcanoes have vents that release gases, ash, lava, and other volcanic materials into the Earth's surface. Conduit allows magma to flow from magma chamber through the vent. Magma chamber stores and collects magma and gases underground. Volcanic eruptions are results of magma being pushed from underground up to the surface of the Earth. The way volcanoes erupt are caused by several factors such as pulling apart the tectonic plates or one plate is forced down under another plate. Interaction of water with hot magma that produces steam and injection of fresh magma into the magma chamber that is already filled with magma. Eruptions of volcanoes can either be violent or not as it is mainly affected by magma's viscosity. It is also known as the thickness and stickiness of the fluid. Viscosity is affected by the following factors, namely temperature, chemical composition, and amount of gases.
Before we end our episode, let us have a short quiz to test if you really understood today's lesson. You can also use your learning activity sheets and join us in answering the Let's Assess part. Are you ready? So let's start.
Directions. Read the questions carefully. Choose the letter of the correct answer. Number 1. Why do certain types of volcano erupt less violent than other types of volcanoes? A. Low viscosity magma and high gas content. B. High viscosity magma and high gas content. C. Low viscosity magma and low gas content. Or D. High viscosity magma and low gas content. Number 2. What do we call to the hot molten material that breaks through the surface of the earth? A. Fluid. B. Lava. C. Liquid. D. Magma. Number 3. What structure enables the flow of magma to reach the Earth's surface? A. Central vent. B. Conduit. C. Magma chamber. Or D. Surrounding vent. Number 4. Which of these does not affect magma's viscosity? A. Chemical composition. B. Concentration of gases. C. Pressure. D. Temperature. Number 5. What structure permits the magma to flow through the vent from the magma chamber? A. Central vent. B. Conduit. C. Magma chamber. Or D. Secondary vent. Check your answer on the screen. Number 1, C. Number 2, B. Number 3, C. Number 4, C. And number 5, B.
Congratulations, grade 9 learners! I'm glad that we were able to finish the tasks in our lesson. If you have questions, you may review your modules or you may ask the assistance of your teachers. Because of circumstances such as demands and stress from the environment, most people will exclaim, "Para na akong bulkan na sasabog," when very upset. When the pressure is high enough, volcanoes erupt, posing a threat to people, the environment, and properties. When we are put under too much stress that we cannot control, we tend to unleash it, which might have disastrous consequences for others. That is why, especially during this time of pandemic, where so much adjustment is required in our everyday lives, we need outlets to relieve our stresses in order not to harm ourselves as well as others. And that ends today's adventure. But don't worry, more exciting science adventures are coming your way. This has been your virtual teacher, Jen. See you again in the next episode of Puerto Princesa